Sum and difference identities, topic we've been working on here from 6.2.2. This is from the worksheet for tonight's homework. Hopefully you have your identity sheet out to help you with this process. And it looks as though we're going to begin with problem number 2. The sine of 195 degrees. So first you must determine how to write 195 as the sum of two angles on the unit circle. And we will do the sine of 135 plus 60. Using our sum identity for sine, we have sine of 135 times cosine of 60 plus the cosine of 135 times the sine of 60. And again, that's coming right off of your identity sheet. You do not have to have those memorized. You will be allowed to use the study sheet on the test. So what is the sine of 135? If you don't know these off the top of your head, you should have your unit circle out. What is the sine of 135? That is root 2 over 2. Cosine of 60 is going to be 1/2. Plus the cosine of 135 is negative root 2 over 2. And the sine of 60 is root 3 over 2. So how do I multiply fractions? I multiply them across. So root 2 times 1 is root 2. 2 times 2 is 4. Plus negative root 2 times 3 is negative root 6. 2 times 2 is 4. And I already have like denominators, so I can add these. I have root 2 plus negative root 6 all over 4. Obviously, that could also be written as just root 2 minus root 6. Next, we have number 6, which is the cosine of 255. So as a sum, I will have the cosine of 135 plus 120. Using my sum formula for cosine, I have cosine 135, cosine 120, minus sine 135, sine 120. So using my unit circle, I know the cosine of 135 is negative root 2 over 2. I know the cosine of 120 degrees is negative 1/2. Minus the sine of 135, which will be positive root 2 over 2, times the sine of 120, which will be square root of 3 over 2. Again, multiplying fractions across, negative times a negative is a positive, root 2 over 4, minus root 6 over 4, and finally I end up with root 2 minus root 6 all over 4. Cannot be simplified any further. Cannot be simplified any further. Moving on. Let's see here. We have the sine of 255. Sine of 255. So again, I can write that as a sum. I just did 255 for cosine, so let's see how sine compares to that. I'm going to have the sine of 135 plus 120, which is going to equal the sine of 135 times the cosine of 120 plus the cosine of 135 times the sine of 120. Okay? So the sine of 135 is root 2 over 2. The cosine of 120 is going to be negative 1/2. plus the cosine of 135 is negative root 2 over 2. And the sine of 120 is root 3 over 2. Multiplying these, multiplying fractions, I multiply across, so I have negative root 2 over 4 plus negative root 6 over 4, which I end up with negative root 2 minus root 6 all over 4. And that was number 10. Next, we have number 12. 12 is asking us to use a difference identity for each of the following. So, first one for number 12, we have the cosine of negative 15 degrees. So, negative means I'm going to do the smaller angle minus the larger angle. So, I'm going to do cosine of 30 minus 45, which equals the cosine of 30 times the cosine of 45 minus sine of 30 sine 45. So the cosine of 30 is going to be root 3 over 2. Cosine of 45 is root 2 over 2. Plus the sine of 30 is 1/2 times the sine of 45 is root 2 over 2. So root 3 times root 2 is root 6. 2 times 2 is 4, plus root 2 over 4, which gives me an answer of root 6 plus root 2 all over 4 for the cosine of negative 15. Turning the page, we end up with 2 more problems here, 17 and 25. 17 is a little bit of a whopper. We have a tangent of 15 degrees. So you remember all the work we had to do for this earlier today? Oops, 15 degrees. So tangent, I'm going to write that first as sine of 15 over cosine of 15. And then I'm going to apply a difference identity here for sine. So 15 I'm going to write as the sine of 45 minus 30. And difference formula for cosine, 45 minus 30. Okay, that leaves me with sine 45 cosine 30 minus cosine 45 sine 30 all over cosine 45 sine 45 or sine 30 plus cosine identity, sorry about that. Let's erase. Cosine 45 cosine 30 plus sine 45 sine 30. Alright. Now I need to evaluate. Sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Minus cosine 45 is root 2 over 2. Times the sine of 30, which is 1/2. That's my numerator. My denominator, cosine 45, root 2 over 2. Cosine of 30, root 3 over 2. Plus sine of 45, root 2 over 2. And sine of 30 is 1/2. Simplifying that, I end up with root 6 over 4 minus root 2 over 4 all over root 6 over 4 plus root 2 over 4. Okay, earlier today we talked about this, dividing by fractions. It's easier to multiply by the reciprocal. So I'm going to end up with root 6 minus root 2 over 4 times 4 over root 6 plus root 2. That simplifies to root 6 minus root 2. A little sloppy here, sorry about that. Waiting for the computer to catch up. So we end up with root 6 minus root 2 over root 6 plus root 2. And we can try to simplify this. First of all, we have radicals in the denominator. That's no good. Okay, so we got to get rid of those. We also can simplify this a little easier if we have what Justin informed us of today. Take this root 6 and split it up into a root 3 and a root 2. Split this root 6 up into a root 3 and a root 2. Advantage being then a root 2 cancels out of every term. So I end up with root 3 minus 1 over root 3 plus 1. Now the only way to get rid of that radical in the denominator now is to multiply by the conjugate, which will be root 3 minus 1 over itself. Okay, and if you struggle to do that, you're going to want to use your generic rectangle. So root 3 times root 3 gives us 3. Root 3 times 1 and negative root 3 times 1 cancel each other out. 1 times negative 1 gives us negative 1. So 3 minus 1 is 2. 1 top, root 3 times root 3 gives us 3. Negative 1 times negative 1 gives us 1. So 3 plus 1 is 4. And then negative root 3 and negative root 3 is minus 2 root 3. So my 2 on the bottom and my 4 and my 2 on top can be reduced to just 2 minus the square root of 3. That's my final answer.